Hello one and all, welcome to another online video by Einstein Academy. In the last video, we looked at learning outcomes A and B from the topic of the gaseous state from the JCH2 chemistry syllabus. In this video, we're going to look at some past year A-level question that test on these two learning outcomes. So let's begin. These are the two learning outcomes that we went through in the previous lecture. So the first question, November 2013, paper 1, question 6. Under which conditions will the behavior of a gas be most ideal? Okay, so in order for a gas to be most ideal, we want the particles to be the most further separated, because of the fact that if the particles are the most further separated, the intermolecular forces of attraction between the particles will be minimal, which will basically fit the assumptions of the ideal gas to the largest extent. So we want the particles to be further separated. And for the particles to be further separated, we want the pressure to be low, because if the pressure is low, the particles will be far apart. And we want the temperature to be high, because if the temperature is high, then the particles will be far apart. Okay, so based on that, we want low pressures and high temperature. So the answer to this question is option C. November 2014, paper 1, question 6. Which statement applies to both ideal and real gases? Collisions between molecules are elastic. So the assumptions of the ideal gas is that for an ideal gas, collisions between the molecules are elastic. However, for real gases, the collisions are actually non-elastic because of the fact that intermolecular forces of attraction actually operate between the real gas particles. So this only applies to ideal gas, but not real gas. So this is wrong. Molecules are in constant random motion. This is actually true. This is one of the assumptions for an ideal gas law. And it's also true for real particles, as it can be shown using quantum mechanics. Molecules attract each other. This is only true for a real gas. For real gas, intermolecular forces of attraction operate between the gas particles. But for ideal gas, it is said that the particles have negligible or zero intermolecular forces of attraction between the particles. So this attraction only applies to real gases, but not ideal gases. Molecules have zero size. So this is actually not true. We say that the size is negligible. You can also say that for real gases, the molecules have non-negligible size. So definitely this is not true. Okay, so the answer will be option B. November 2015, paper 1, question 33. Which statements are assumptions of the kinetic theory as applied to an ideal gas? The molecules of the gas have no mass. So in fact, the assumptions of the ideal gas doesn't say anything about the mass of an ideal gas. And for real gas and ideal gas, they actually all contain masses. Because like if you go by the equation PV equals to nRT, the number of moles, you can change it to mass over mR. So it must be true that even for an ideal gas, the molecules actually have mass. Okay, so this is wrong. The molecules of the gas are in constant random motion. So this is, as seen in the previous question, this is true for an ideal gas. Okay, the molecules of the gas have no volume. This statement is a bit funny because it says no volume, right? But in the assumption is that negligible volume. So the question is negligible volume, is it considered to be zero volume? But if we look at the options, right? If one is wrong, then the only option available is 2 and 3 is correct. So we have to accept the fact that like the negligible volume that is stated in the ideal gas assumption can be equated to be no volume, but kind of like strictly it's not true. Okay, but in MCQ, we always choose the best possible answer. So so the answer for this question will be option C. Last question, November 2009, paper 3, question 4a. Describe 3 ways in which the properties of an ideal gas differ from those of real gases. So for this, I'm just going to refer to this. Okay, so out of these 4 assumptions, right? The assumption that ideal gas particles are in constant random motion, this is true for ideal gases as well as real gases. So the assumptions 1, 2, and 3 are the one that differs between real gases and ideal gases. So real gases have significant interatomic or intermolecular forces of attraction between the particles, while ideal gas have negligible. And then for real gases, the volume of the gas particles is non-negligible as compared to the volume occupied by the gas, and this differs from that of an ideal gas. And finally, for an ideal gas, the collisions are perfectly elastic, but for real gases, the collisions are non-elastic. So these are the 3 ways in which the properties of an ideal gas differ from those of real gases. Okay, so This basically sums up the questions that is asked in A-level that is addressed to these two learning outcomes. So I hope that the material that you learned from the previous lecture does help you solve this type of questions. If you like this video, please hit the like and subscribe button and stay tuned for another episode as we'll look at learning outcome C from the topic of gaseous state from the JCH2 chemistry syllabus. So thanks for tuning in and see you once again.